I trust and pray all of you are doing well. I am Mr. Ish. Thank you for joining me. Regular hexagon area formula, but using double integrals. That was a request from a specific viewer, and I'll show it to you. Much of this will be repetitive in terms of what I've presented. Hexagon using single integral. Consider n minus 2 number of sides. Minus 2 times 180. You have a total internal angles of 720. Divide that by 6. Each of these internal angles is 120. And you have 6 triangles you can draw in a hexagon. And this represents a single triangle, as you see over here. And you can see the breakdown of the angles. This right here would be your other 60, and that right here would be your 120, and then your hexagon will continue. This can be one of any of these triangles that you're seeing. Trigonometric ratio 30, 60, 90, 1 root 3, 2, all of that can come into play. So given all of this, we can represent a diagram over here so we can get everything started. How do you want to do this? The easiest way, using double integrals, or a more involved way using double integrals? Why not we go for the easiest way? This can be one of these triangles you see over here, except we're going to focus only on this half a triangle, and I'm going to dot this out because we don't need to look at a complete triangle. This here is 0 comma 0. Obviously this is a over 2 comma 0, as all of this would have been in a, that dimension that you're seeing. If this is a over 2 0, then that would be 0 comma root 3 a over 2. That's what it would be. As you know, 1 root 3 2. Those dimensions are good. Now all we're doing is looking at that for our double integral procedure. But what will we do at the end? We know there's 6 triangles, we have to do it times 6. But we also know I split one of these main triangles into halves, so we have to do it times 2 to recapture this portion right over here. Because the double integral I'm doing is only capturing this part, and I want to multiply by 2 to capture the other half. So I know I have to do a times 6 and a times 2. Times 2 for this lost half of a triangle, times 6 because there's 6. So let's work with what we have over there. I have this interval right here which is going to integrate upwards. This limit here will go straight up, no problem. This limit right over here, it's going to track the line, so I need the equation of this line. What can it be? Well, you have 2 points. You know the slope over there is going to be minus root 3. Y is equal to minus root 3x plus your y-intercept root 3a over 2. Solve for x. You have a y minus root 3a over 2, all divided by minus root 3 is equal to x, but it's also equal to this flipping around, and you're doing root 3a over 2 minus y divided by root 3. That's equal to this equation right over here. Now look at my integral with respect to dx. This limit here is 0, stays as is because it tracks upward. This limit here will converge, and it will be exactly this. Root 3a over 2 minus y divided by root 3. All of this dx integral will integrate upwards with respect to dy from 0 up to that point, root 3a over 2 dy. That right there will be the double integral, which will give you the area of just this. But then we have to multiply it by 12 for these parts right here to capture the entire regular hexagon area, and this is what we need to do. The antiderivative here is an x. You're looking at it from 0 and all of this, root 3a over 2 minus y divided by root 3. Do this computation, you just have a root 3a over 2 minus y divided by root 3. This will now go into your dy integral, but this over root 3 can be pushed outside right over here underneath this 12. So suddenly everything becomes 12 over root 3. Now you have this entire integrand, root 3a over 2 minus y with respect to dy, because the dx integral is used up from 0 up to root 3a over 2. That's what we have. What's the antiderivative coming from here? It's a root 3a y over 2 minus y squared over 2. Everything from root 3a over 2 and a 0 and a 12 over root 3 sitting outside, which will multiply. Let's look at this part only right here. Then we'll multiply with this part right here. Root 3a over 2 is coming here in place of y. You'll have a root 3a times a root 3a over 2 will be a 3a squared over 2, which is an over 4. Bring it right here. Root 3a over 2 square is a 3a squared over 4 over 2, which is an over 8. Common denominator is an 8. 4 goes in 8 2 times. 6a squared minus 3a squared is a 3a squared over 8. Multiplying by this 12 over root 3. All you have to do is simplify that, and you'll have your area of your regular hexagon. Simplify it. 4 goes in 8 2 times. 4 goes in 8 3 times. Root 3 goes in here root 3 times. 3 root 3 a squared over 2. That right here represents the area of a regular hexagon, and we've done it. Again, remember I showed you the easiest way, doing a representation such as this, because it's easy. You're only tracking one limit which is deviating, the other limit is going straight up. It's very easy. Why do something harder when you can do something easier? The other option could have been doing something like this, like that. You'll have a 0, 0. Here you'll have a a, 0. This represents your entire a side, your one side of your hexagon. And then you're looking over here, which would be a over 2, because it would bisect midpoint of this segment upwards, comma root 3a over 2. Now you'd have to determine this equation, then you'd integrate dx, this interval upwards with respect to dy, and it's just more work. This is easy. Do half, multiply by 2, multiply by 6, you're good. And the procedure is completed and I've showed you. Have a good day.